Okay, I'm working problems here from 2-3. And just a few different problems, not all of them from this section, but just to give you an idea of what's going on. This is about creating linear equations. At 10 a.m., airplane number 1 has an elevation of, so it's 10 a.m., 9,500 feet. And this is the change. It's climbing at a rate of 200 feet per minute. At 10:15, which is 15 minutes later, airplane 2 has an elevation of 35,540 feet, and it's descending at 250 a minute. So the first one's pretty straightforward. We're at that 9,500 feet plus the elevation rate of its gaining plus 2 times t. So there's our equation for the climb. It's the 9,500, the current, plus the rate of change, 200 times t. Because they want to know the time at 10 a.m. Well, here's one of the dilemma, or the problems. This second plane, the data was given to us at 10:15. So assuming that things were in the same pathway, we have it here and it's on the way down. Well, we wouldn't need to know back in time, what was it back up here? And that was 15 minutes earlier. So we can say 35,525 minus, because it's descending, 250 times t minus 15, because it was 15 minutes earlier that occurred. So that's going to be 35,525 minus 250t plus 3750. Let me just verify that. Yeah, 3750. So now we can add this elevation to this elevation, and that's where we get the 39,290 minus 250t. That's where that comes from. Now we're going to find out the time they're going to be the same elevation, and that's where we take the 9,500 plus 200t and set it equal to 39,290 minus 250t. So I'll add 250t to both sides, and I'll subtract the 9,500. And I end up with 450t. Can I scroll this up? I can. Okay, 450t equals that 39,290 minus the 9,500. And I get 29,790. I can divide both sides by 450. So t would be equal to 66.2 minutes. Minutes. Okay, so that's our 66.2. Now it wants to know what is the elevation at that time. Well, this one's not so bad. We could plug into either of them. I'll just do the first one. So at 9,500 plus 200 times 66.2, what's that going to be? I get 22,740. And that's the answer there. Now we could have plugged that same 66.2 in the other equation up here and gotten the same result. Okay. Pause if you need to pause, or back it up now and pause. A moving truck rental company charges $33.95 to rent a truck. That's the base price plus 67 cents per mile. Suppose the function C of D gives the total cost of renting a truck for 1 day if you drive 23 miles. So that's where our cost would be the basic cost for the truck plus the per mile cost. And I would have called it probably not C, I guess D for distance. So give the total rental cost if you drive the truck 23 miles. Give the function notation. So that's why it's the function C of 23, because it's the function C, equals what? So we're going to look at 33.95 plus 0.67 times 23. And I get 43.36. And then suppose you have $140 budgeted to move. What is the furthest distance you can drive the truck? So we take that 33.95 plus 0.67D, set it equal to the budget of 140. We can subtract 33.95, and we have 0.67D equals 106.05. Then we divide it by 0.67. What is D? I get 158.28 miles, so that's where they said 158. That's it. The next one here, manufacturing companies usually have, this number 4, have two types of costs: fixed costs, sometimes called overhead costs. Okay, costs not related to manufacturing of each item. The fixed costs include things like rent, a base level of utilities, and a base level of salaries that must be paid even if the company does not make any products. Variable costs depend on the number of items manufactured. Variable costs include things like parts and raw materials. For the products, higher utilities, higher salaries. As a manufacturing company increases the number of items it produces, the fixed costs do not change, but the variable costs do increase. So your fixed costs are like your y-intercept. One company manufacturing high-end racing bikes, the monthly fixed costs are $31.30. That's why that's a fixed cost there. The total cost to manufacture 23 bikes is $15,895. So assume the total cost C is linearly related. Okay, what are we going to do? So I'd say our C of 23 is going to be that 31.30, the fixed cost, plus we don't know what it's going to be. We'll call it M times 23, because that's 23 bikes, equals 15,895. So in this case, we're solving for the slope. So we can subtract 31.30 from both sides. Then M times 23 is equal to I get 12,765. Then we can divide by 23, and we can find M. And I get 555. So that's why we have 3130 plus 555x. So then what's the cost to make 35 bikes? So C of 35 would be equal to 3130 plus 555 times 35. I get the 22,555, which fits with this answer here. And the cost to produce each additional bike is, well, that's our slope. And that's it. Okay, I hope that helps. If you have any problems with the section still, please let me know.